information. So my name is Kris Knight. I'm from NASA Ames Research Center, and it's good to see a good crowd today, the last day of this year's Flight Software Workshop, and it's great to be here in person again. I'm working with Dr. Jeremy Frank, who probably about half of you know, just because he seems to know everyone. And I am not a planning and scheduling person, so if you have a planning and scheduling question, ask it in Slack or send Jeremy an email and tell him that I sent you his way, so he can yell at me next week when I see him at JSC and at Ames. So this is a little very brief overview of what Gateway is about. It's a bunch of modules that will be orbiting a highly elliptical orbit around the moon. It's meant to be a gateway to do lunar research and then also be a way station to go on to Mars and a demonstration vehicle. Obviously, it has a large number of modules, which for folks in the room, it's an eye chart there to see all those modules, but it's great to hear Merrick talk yesterday for the ESA on the IHAB module and Esprit, I'm not sure how to pronounce it. But we're working primarily on the core systems, the Halo and the PPE modules, and looking at planning and scheduling of the systems, of vehicle systems management, so maintaining the vehicle while it's unoccupied. Part of the design of this, which is exciting to me, is that it's going to be idle, empty for maybe not truly idle, because I'm guessing we're going to spend a lot of unmanned resources there to do research on the moon, but it will be unmanned. I've heard estimates of 10 months of the year out of the year, and that's quite a long time to operate a system that will, for 2 months of the year, be occupied by humans. So maintaining a system that is habitable is an interesting challenge, and we're hoping to provide planning and scheduling that will support that as part of the vehicle systems management project, program, whatever you call it. So part of the challenge is that VSM is bringing a lot of interesting problems over the planning and scheduling community. Again, this is not really my expertise, but we're basically going to be taking a number of different approaches and evaluating the different plans that are produced to determine which is the most efficient for the goals that are given to us. So here's kind of a high level. We have the CFS lollipop chart. Well, I'm going to call this the honeycomb chart. All the major components of VSM, and we're smack dab in the middle in the yellow, kind of, well, I'm colorblind, sorry, kind of orangish, whatever color it is in the middle there, but just kind of give you an idea of the scale of VSM and how planning and scheduling is just one small part of it. The VSM planner and scheduler are really looking at 3-hour windows of time with some overlap, so that there's some if we have issues, we can resolve them before the next window. We're not a real-time planner. So if anyone says, well, how does it work in real time? Well, we're not. We don't have any hard scheduling or hard real-time requirements on our software. It's really more of a longer-term planning and scheduling. So basically, fundamentally, there's a tool called Goal Tracker, which will hand us goals, and then the planner will try to find tasks that meet the goal requirements, and then hand that off to the scheduler. We're looking at what are the preconditions, what are the resources that are required to complete those goals, complete those tasks, and complete the goal, and then execute those tasks through the scheduler. This is all through actually one or two core flight software applications. Right now, we're kind of early development, so whether it's one or two is to be determined, but basically we're core flight and that's where I come in. I'm the core flight expert on the team. Because we have the honeycomb chart, we have to have the bubble chart, the lollipop chart, and again, we're one small bubble on all of these. You know, these yellow bubbles are all the different VSM core flight applications. So quite a big system. Kind of how the different applications will talk to each other. The goal tracker will be tracking our progress towards completing the goals, and there'll be the scheduler will be executing through the dispatcher the tasks as we proceed through the scheduled plan. Here's kind of a high level planner architecture. So we're receiving the goals from the goal tracker. We're doing some reasoning on that with the number of algorithms, number of planning algorithms. We're pulling data out of the onboard data management system to find out what resources are required for what tasks will meet which goals. And then the heuristics will be evaluating the different algorithms to determine which plan is the best, and we'll start scheduling that for execution. So again, the planner is really to enable the human operator, when either from the ground or on the station, to will be able to offload workload to the planner to manage resources on the station, which is kind of a different way of thinking. You know, looking at ISS, a lot of operations on ISS is really managed by the ground. So this is very much trying to automate a lot of the operations on the gateway vehicle. There'll be other systems looking for vehicle constraint violations, and we'll be trying to address those violations through goals and mapping the tasks to those goals, and then creating plans for active mission goals. So, then the scheduler will, once the planners develop the timeline, will work through the schedule to execute the plan, and again managing task resource requirements. Of course, check for validity of the plan to make sure that's not given the plan that can't execute. A little bit of a flow chart, again, kind of related to the previous chart. And sorry, that's a really eye chart. I refer you to the PDF on the on the Google Drive. But again, this is fairly preliminary work. We're really just kind of doing initial evaluations of the planner system and integrating it with the flight software community there at JSC. So a big part of what we're working with right now is the onboard data model. There's quite a complex data model that describes all the systems that the planner will interact with. And so we're trying to work through with the JSC data modeling team to flesh that out and work how we'll be retrieving data from that database. In fact, actually, I know there's a talk later this morning about SQLite for flight systems, and I think that's going to be very interesting to me because that's kind of where I live, is the database side of things, and so we're spending quite a bit of time managing that system. And why is that chart? Oh, it's animated. Yay! I really should look at these things in presentation mode instead of just. But so, anyways, skipping through all the animation, because who cares about animation? It's again, we're retrieving data, or receiving plans from or goals from the other applications in the VSM, whether they be fault manager or goal tracker or the other applications. Where the planner will again retrieve data from the database and interact with the database to plan for addressing those requests, and then there's output that tracks the goals, and again the schedule. We talked about that. And that's my slides. I'm ahead of schedule, right?